On the interval, in what interval is f of x increasing? So what do we need to examine? The second derivative? First derivative tells us increasing, decreasing. Second derivative tells us about concavity. Are we interested in concavity right now? No. First derivative and second derivative, only the first. Oh, you actually need to see what's going on, don't you? There you go. So what is, here we go. What is f prime of x going to be equal to? What is f prime of x?
2x over x squared.
2x times. Is that correct?
Yeah.
So you have f prime of x is equal to 2x over x squared minus 1. So you're interested in when that is what?
0.
When that's 0. So that's 0 when what? Or undefined. And that's going to happen at x equals -1, 0, or 1. So then how many regions do you need to test? 4 of them. This is your x value. This is your f prime of x value. So we know it's 0 here, undefined here, and undefined there, meaning it could change. So let's plug in a huge positive number. Oh, look, it's going to be positive. Plug in a huge negative number. What's it going to be? You sure? It's going to be negative because you're going to have a negative on the top, right? And then what about 1/2? Plug in a half. You get positive on top and? Really? 1/2 squared minus 1 is positive? No, it's going to be negative right here. And then what about -1/2? You sure? It's going to be negative on top and negative on the bottom. So what is it going to be? Positive. You guys are something here. So what do we think? Does that match any of the answers? It does? It says, where is it decreasing? Well, look, where do we see it's, okay, look, by what we just figured out, it's decreasing there and there. It doesn't match perfectly any of those 5 things. I understand, but what I'm saying is what we got, is there anybody that disagrees with our, if this is the first derivative, if this is the first derivative right there, what would you like to say do any of these answers match? I guess my question is, did we fill in this chart correctly if this indeed is the first derivative? I think we did. Let's see, we plug in a huge positive number, it is positive, right? Plug in a huge negative number, it's going to be negative because the bottom will stay positive, but the top will be negative. Plug in 1/2, and you get positive on top and negative on the bottom, so it's negative. Plug in -1/2, you get negative on top and negative on the bottom, so it's positive. So based on this assessment, this right here is what we have for areas where it's decreasing. The problem is it doesn't match one of those answers, right? The answer is C, so it looks like we have a little bit of extra stuff in here. So here's the thing. If this analysis is correct, that means we did something wrong above. What did we do wrong? Is that this right here, x squared minus 1 has to be greater than what? It has to be greater than 0. Can you take the natural log of 0? No, you can't take the natural log of 0. E to what power is 0? Doesn't happen, right? So it has to be greater than this. So x squared has to be greater than 1, right? So what's the domain of this function? The domain of this function, so if x squared is greater than 1, here's the domain of the function right here. The purple. So this right here, not in the domain right there. So which one is it? X has to be less than -1. Why can't it equal -1? Because -1 isn't in the domain, kids. Look, it says specifically greater than, right? It can't be equal to. That's where it comes from. The graph of f consists of 4 line segments in a semicircle from -3 to 5. Let g be the function. It's the integral from 0 to x. Use the information of the problem. So g of -1. So if we actually were to use this definition, we know g of x is equal to the integral from 0 to x of f of t dt, right? So what is g of -1 equal to? It's the area under the curve from 0 to what? -1 of f of t dt. So where is that? This right here, where is that area? It's from 0 right here to what? -1. You're going backwards. So what's that area right there? Negative what? -1. because you're going backwards. You're going from 0 to -1. So this one is -1. And then you do g prime. Now we have to use the fundamental theorem of calculus. What is g prime of x going to be? F of x. It's going to be f of x. Fundamental theorem of calculus, essentially one of those parts says you can undo an integral by taking its derivative. There's technically you're doing the chain rule, but what's the derivative of x? 1. So there's an invisible 1 there. You always use the chain rule. It's just usually not visible. Okay, so you're doing literally g. So g prime of -1 is f of -1. What is f of -1? 0. So this is plus 0. And let's keep going here. And then it's g double prime of -1. Well, first let's sorry. Jumps again. I don't know why it does that. So we want to do g double prime. So what is g double prime going to be? That's going to be f prime of x, right? So g double prime of -1 is going to be f prime of -1. So go to -1 right here. What's the derivative at that point? Over 2, up 2, right? Sorry, over 2, up 4. So we know that g prime is f of x, right? So g double prime is f prime of x, right? So this graph is f prime of t, but f prime of x. What's the rate of change right there at that point? What's the rate of change? What's the slope of the line right there? Right here. 2, because you're going at that point, it's a line segment. It tells you it's a line segment. So this is going to be 2. So what's the answer going to be? C. Okay. So you have the rate at which it's happening, right? The rate at which it's happening. So what you're going to need to do is it says what? Using 3 equal intervals, you're going from 0 to 12, right? So what are your intervals going to be? 0 to 4, 4 to, and 8 to 12. So at 0, you're at what? 0, 12, right? And then at 4, where are you? 4, 10. And then at 12, where are you? 12, 8, right? And you're supposed to use right Riemann sums? Using a right Riemann sum with 3 equal intervals. 0, 12. Oh, I did 8. Not 12, 8. It's 8, 12, sorry. That's confusing. Do you see what I did there? What's 8? Oh, 12. And what's 12? Great, good job. I didn't do all the points is what I'm saying. So then at 8, what is it? 12. And at 12, what is it? That's why I was confused. Okay, so you're doing 3 subintervals and you're doing right endpoints, right? So look, what it's saying is this is the starting value. There's your x-axis, and there's your y-axis. So if you're going to draw the right intervals, what are they going to be? What are they going to look like? Like this. Are we good so far? Rectangle going to be? The width of each of them is 4, right? What's the height of that first one? 10. So this is going to be 40. What's the next one going to be? The height is what? 12. So it's going to be 48. And then it's going to be 32. So if we add all those together, it was 40 plus 80 is 120, right? Okay, so that is our approximation. So this curve, where does the curve actually travel? The curve does something like this, right? Do you agree? It does something like that. So we use the right endpoints to get the approximation, right? But it's not asking us for the approximation. What is it asking us for? The average, right? If you have a whole class full of people and you want to get the average test score, you take everybody's test scores, you add them together, and then you divide by the number of people who took the test, right? How many data points you have. In this case, what do we have to divide 120 by? Oh, no. What's the width? 12. We have to divide it by 12 because we want the average value from 0 to 12. So which one is it going to be? Is that the answer it gives you? What's it come out to be? Oh, 12. Thank you. So what's it come out to be? 10 centimeters per minute. Right there. Is that it? Good. What you're looking at, kids, the average value of a function, the function average of a function is 1 over b minus a of the integral from a to b of f of x dx. That's the average value of f of x from a to b right there. And that's essentially what you did. But this right here was 1 over what? 12, because you're going from 0 to what? You're going from 0 to 12, right? And then instead of doing the actual integral here, what did we do? We estimated up above, right? So our estimate from above was 120, and the width was 12, so our function average is going to be 120 divided by 12 is 10. Yes. The region R is bounded by the curve x equals y squared minus 1 and the y-axis. What is the volume generated when the region R is rotated about the y-axis? What's your first step? We did these in this class. Draw a picture. Draw a picture. We know that this function crosses at -1 and, well, -1 and 1, right? And then when y is 0, what's x? Yeah, so it looks like this, right? Sideways parabola. So it's bounded by that and the what axis? The y-axis. So you're bounding it here and there. I can't turn the pen with the highlighter, unfortunately. So what are we rotating it around? Yeah, so draw that reflection. It's going to be right about there. So let's say it's not bad. Right there, and you're rotating that. So you actually have some options here. Do you want to do this? Do you want to draw wash? What do you want to draw? Do you want to draw discs or cylinders? Discs. Discs are a lot better this time. So if you use discs on this, draw one of them. There it is. Is it going to be dx or dy? Dy, right. What's the lowest y value? Or we could do 2 times 0 to what? Why can't I do 2 times 0 to 1? Symmetric across the x-axis. Does that make sense? It just makes it easier. You can plug in 0 instead. It's going to come out to be the same thing. Yeah? Okay. So what's the area of a circle is pi what? So it's pi times the radius squared dy, right? So we need to write the radius in terms of y, right? Well, this distance, they already tell you what is that distance. X is equal to what? Y squared minus 1. So in this case, r is equal to, oh, look at that. Did they set this up for you nicely? Yeah. So it's 2 pi from 0 to 1 of y squared minus 1 dy. And what do you do to that? You square it, because it's pi r squared. Nice. What do you have to do before you integrate that? What's our first step in integrating this? Square it, yeah. You have to. From 0 to 1 of y to the 4th minus 2y squared plus 1 dy. And now we just get to fraction land. What do you end up with? 1/5 y to the 5th minus 2/3 y. Oh, why am I integrating? Oh, I'm supposed to be integrating. That's why. Amazing. The monologue with myself is weird sometimes. 0 to 1. Now, this is why it was so nice to go from 0 to 1. If we had to go from -1 to 1, you'd have to deal with all the plus or minus fractions. Now, when you plug in 0, what do you get? So what do we really have to worry about? 2 pi times 1/5 minus 2/3 plus 1. So 2 pi 5th plus what? 1/3. 2 pi times, what are we going to get? 3 plus 5 over 15 is going to be 16 over 15 pi. Is that one of the answers? Yay! I can do fractions. Woo! Sweet. Such a good answer. Inflection point is where it changes concavity. How do you identify where potential inflection points can be? How do you find out where the second derivative is 0, right? So in this case, it's not asking how many inflection points could it have, or at most, it's asking how many inflection points does it have? How many different ways can you make this equal to 0? Well, hold on. Is that ever equal to 0? No. So it could potentially be 1/2, 3, or what? -5/4, right? But the thing is, are all of those necessarily inflection points? No. Here's the thing. So what do you have to do? Here's what you have to do. You have -5/4. You have 1/2, and you have 3. You have that's the x value, and now you need the h double prime value. You don't care what the value is, you just want to know if it's positive or negative, right? So you know it's 0 there, 0 there, and 0 there. So you have to plug numbers in and see what happens. Plug numbers in and see what happens. Kids, a great way to do this, if you want to make a chart to keep track, because it's really easy to get it wrong, the way you do it is you write down all your pieces. E to the x minus 1, 2x minus 1 squared, x minus 3 cubed, 4x plus 5, especially since this is not a calculator one. And then you're testing a whole bunch of things, and then your product, like this. So like negative, huge number, right? Well, this is, oh, we already established that those are positive, right? That's going to be negative, and this is going to be negative, right? So if you multiply those all together, what do you get? Positive. So it's positive right there. What's between negative 5/4 and 1/2? That's a really easy number to test. 0. Thank you. Plug in. Oh, we already know what's going to be positive, positive, negative, positive. So what's it going to be? Negative. Between 1/2 and 3. How about 1, right? So what do you get? Positive, positive. We already established that. And then you get negative, positive, negative. So it's negative right there. And then, yeah, that just eliminated one of them. Plug in, oh no, infinity. It's positive, 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 and positive. No, it doesn't have to. No, but you're verifying it. So in this case, how many inflection points are there? There's 2 of them. So there's going to be an inflection point here and here, but not at 1/2, because does the concavity change at 1/2? No, it does not. There you go. Yes. One of those things is this. Ready? Help you out here. F double prime less than 0 makes you feel unhappy. So it's concave down, right? F double prime is positive, which makes you happy, concave up. It gave you the acceleration. So how do you turn the acceleration into velocity? You know v of t is equal to the integral. I'm writing this in a poor fashion. The integral of a of t, right? You have to integrate it. You have to integrate acceleration. But if you integrate acceleration, how many different integrals can you get? As many as you want, right? Because the constant can be anything. Do you agree with that? So how do we fix what that constant? Oh, they tell us that v of 0 is 1. That's the initial condition. So here's the thing. You are trying to integrate, and this is where it gets fun, t squared plus t over t squared plus 1 dt. You're trying to find the indefinite integral of that right there. What do you do? How do you do that? You don't know how to? No? Okay, so let's say you got to there and you're all sad because y'all can't integrate that, right? They're giving you 5 potential answers. How could you test to see if one of those answers worked? You could take the, first of all, make sure it goes through 0, 1, right? You could do that if you wanted to, but you could just start taking the derivative and adding it together. You could take the derivative and add it together. I want to check. That's a fraction, right? What's one way to rewrite a fraction? Anybody remember how to rewrite a fraction? What am I doing? What is that? Oh, it's a division. I'm doing division. I'm sorry. I'm doing division here. You do leading. Remember polynomial long division? Like, what is that thing? You do leading over leading. What's the leading term outside? T squared over t. Oh, so it's going to be 1. And then you multiply and you get t squared plus 1 because I multiplied it both right there. Do you remember this? Kinda, maybe, right? So if you do this now, what do you have to do now? You subtract the whole thing, right? The t squareds cancel. What do you end up with? T minus 1. Now, can you go any further? No, because the degree here is what? The degree is 2. What's the degree down here? You stop once the degree is less than. So what do you now know? You now know that t squared plus t over t squared plus 1 is equal to 1 plus t minus 1 over what? T squared plus 1. Exactly. So essentially what we've rearranged this to is this integral. The integral of 1 plus t minus 1 over t squared plus 1. We're getting closer. We're getting a lot closer. Fractions. Yay. Woo. How about this? 1 plus t over t squared plus 1 minus 1 over t squared plus 1 dt. Have we done any calculus yet? Have we done any calculus yet? Really? Have we? No, we haven't done any calculus yet. But here's the thing. Each of those things you can now integrate separately. The integral of 1 dt plus the integral of t over t squared plus 1 dt minus the integral of 1 over t squared plus 1 dt. What's the integral of 1 dt? The integral. Dt. T, thank you. Plus, oh, what do you have to use now? U sub? And what's the integral of 1 over t squared plus 1 for the win? Tan inverse. Don't say tan to the negative 1 power. Please don't say that. Plus c. Right. So we have to use u sub. What's the u substitution going to be on this one? Oh, now does it work? Du is equal to 2t dt, right? So what does dt equal? Du over 2t. So now we have the integral of t over u times du over what cancels? That's the magical thing that you were looking for right there. So you have 1/2 the integral of u to the negative 1 du. What's the integral of u to the negative 1? Ln of what? Ln of u. So we bring all this down. We have t plus ln of u minus, what was it? Tan inverse of t plus c. Now we just need to check, is that answer actually there? Is that actually there? Which one is it? Can you find it? They all look so similar, huh? First of all, we're not subtracting it, we're adding it. So that one's gone, that one's gone. It is E? It's not, it is E? Uh-oh. Did I lose a negative sign somewhere? It's not here. I think it's D, isn't it? No, the answer isn't even here. It should be minus the tangent, right? It should be plus the 1/2 and minus the tangent. Yeah, so let's say, I'm going to change it. Yeah, there it is. Yay. Okay.